Thank you very much, Phineas, for inviting me to give my presentation. Before that, maybe I can take a liberty to comment a little bit on the Kilimanjaro issue, that we are really not talking about Kilimanjaro as the peak. We are talking of the saddle, which is a huge area available, and we need to protect it, but that is available for a lot of different astronomy potential observatories. So now here in my presentation, I am primarily concerned with combining a little bit of all the things that we are hearing about what we can do to develop, and this theme of economic use of astronomy. How do we go about doing that? So this is really an effort to really combine all my experiences, perhaps, and all the experience of people whom we have worked with in order to get some idea. This is more like a brainstorming thing rather than an established thing. We are still asking for opinions, comments, ideas, and how to improve our approach to how to really progress in Tanzania in terms of astronomy. So my idea is that we have to start, for example, with education, the training part, the research, the outreach, the applications, and cooperation. So I'm going to go through these one at a time. So in terms of education, what I mean by education is everything you do while you are at school. What I understand, everything you do up to school level is called education, because there you are really trying to understand the basics and all the general aspects. You get your experiences, and it starts from home even. When you talk about astronomy, you have to take your child out. You have to show them that there are so many things around you. Question them, and their children are even ready to question, because they are the people who are most interested in what's happening around them. They learn by experience. So the home is the first place where we start our education, and our parents have also to be aware of this. And we use as generations go on, the education of the society increases. Then we talk of elementary school, where we understand that you have to introduce a lot of basics. And the whole issue about basics is that, and the elementary education is that if you start going wrong at that stage, you start a process that is never-ending confusion after that. So we have to be sure that our elementary education is really well-based, without misconceptions, with correct ideas, and at least the knowledge that is available is imparted at that elementary level, but which can now be improved. And then the primary school. So that is where the books start coming in. When the books start coming in, that's when confusions, a lot of confusion. For example, in Tanzania, we find that a lot of people are teaching basically from the books, even if they have not understood it, because that is how they've taken it. That's how they would continue. So nobody questions, perhaps. So we have to really look at our curricula, and including secondary school, we have astronomy topics up to secondary school. And the primary school, there are solar system, the weather, all these are related to astronomy. And in secondary school, we also teach in geography also, we teach our seasons, climate. And there's so many misconceptions already still continuing within that. And in astronomy now, we have a better textbooks, for example. So we have to make sure that people understand those things based on what they learned from their experiences and for what they learned before they came to the secondary physics syllabus has a specific topic on astronomy. And high school, unfortunately, we start forgetting, although we have the physics, and we now start to focus on astronomy from a physics point of view, perhaps, but that also has to be put in. Now, training, I start training in astronomy. Training is from university level. For me, you start training people from you, because you are now asking people to specialize, etc. So here we are trying to say that really we need to get really strong people doing physics and mathematics degrees. And also, of course, the other fundamental sciences, the basic sciences, the chemistry, biology, computer science also, because that is now the way of the world, so etc. And then here we are also, in a way, at the first degree level, do we offer astronomy as a program, or do we offer astronomy as courses, as several courses within the physics or whatever other program that the university offers? That is a choice that we have to make also. One of the other parts at university level, we say, because teachers have already gone out with a lot of misconceptions, a lot of lack of knowledge, etc. They're out in the schools. They don't know anything of almost anything about astronomy. In fact, when they're teaching the topics, you'll find that they will even skip topics. They'll be, it's like exam-based teaching. They look at, oh, what kind of exam questions? And there are a few that are often always regularly asked, and students will know that much only. So in service and hands-on teacher training, we feel is an integral part of our training needs, training that we need to do. So that's, we are already doing it. We already started through NASE and the OAS initiatives. So we are started that. For now at the postgraduate level, that is where you really start going into now focusing on astronomy, now astrophysics, you can say astrochemistry, astrobiology, all those things, and data science, everything can now become at a postgraduate level. Currently, we have succeeded, for example, in having at least one master's degree graduate, Daudi Mazengo, who is from University of Dodoma, to be able to do an astrophysics dissertation for his physics master's degree. So that's how we can go also. We take the current programs and we focus, we ask people to focus on astrophysics or astrochemistry or astrobiology within their own master's level research areas. So we will need here again, I think we need support from external expertise. For example, Miriana has been crucial in developing our capacity at this master level. So we are very grateful for that. And we need even more people to just be available. We may not be able to really compensate in terms of the effort and the time that they give, but that is extremely necessary. And now we have to also think about what type of, where do we get the PhDs, because we need to get exposure. If somebody is being trained only locally, the only experience that they will gain is local experiences. We don't have too much to offer, so they should go into groups that are already doing established research, and they join the group, they understand about the general aspects of that area and also overall levels, and they do their own PhDs also. In terms of skills training is also extremely necessary in terms of certification of different skills. These are the kind of professional training. For example, we are saying astro tour guides. That's something which I'm really focusing on, that we need to have training of astronomy for our tour guides. And the skills for data reduction analysis, obviously we are going to talk about this from my colleague, Dr. Saidali, who will be giving a lot of ideas about how this has to be done and its impact on our social and economic development. The certification is now under a particular society, which is a professional society, and they can give certification to the tour guide so that they are now established, that they can be employed or they can run their own tour, astro tour guiding businesses also. Now, research and development. So research and development, we talk of research as a lot of this area is basically capacity building. We have seen in Kenya, for example, we know that the DARA project has helped them to produce, I don't know, maybe 20, 30 PhDs and uncountable number of masters. So in the same way, we need to have that type of focus. If we have the more people who have, we reach a critical mass from which we can now create our own areas and our own knowledge, and push the astronomy and astrophysics and all the other sciences forward in terms of research. To use, we have galactic and extragalactic astronomy, which we have been lucky to have been introduced to through Dawdi's work under Mariana's supervision, that this is an area which is open to a lot of research questions. She had that in her talk. She gave us all the ideas in her talk also. And in terms of whatever we are doing for the Kilimanjaro project also, we are talking of the black holes, and really that will be really cutting edge research if we are going to able to, once we are going to be able to have this capacity here in Tanzania. The mathematical astrophysics group, we have very strong, we have our physicists or mathematicians in at the University of Dodoma. We have at the University of Dar es Salaam. We have in the Sokoine University of Agriculture. So we have mathematical astrophysicists who will also be supporting our development of models and how to understand modifications perhaps of the theory of data science, because this is one of the areas that we really need to be focusing on in terms of being our capacity to store, to analyze, and to use and understand data. Virtual observatories, these would be useful in terms of where, for example, if we are talking of meteorites, we are tracking meteorites. I think we should all be working on young people can use the data that is available. Light pollution work, we are definitely, because this is connected with astrotourism in terms of dark skies and astrotourism. So we really need to focus on that also. Education in terms of research, so that we really propose ideas in curricula and books that are really right and correct. And we are also working a lot on improving our Kiswahili terminologies to create lexicon that are really understood. You understood from Carolina's presentation that really, even if we are going to use to get words in Kiswahili, we need to start with words that are already familiar, already in the society. People are already using them. So we use the word that is familiar to bring in the new concept in astronomy, so that the initial idea is already there. It is something related with for example, if you are talking of a cloud, so the cloud like wingu, so wingu should become a word that should go into cloud computing, something like that. So we should create Kiswahili lexicons, and we are already doing that, but that is still a very, very, a lot of effort is required there. Outreach, this is something which I've been doing, which I've said this is where it's been my focus almost all my life. So starting from schools, really trying to encourage schools to have their own clubs. And it's not really a matter of having even telescopes. The interest is how to go out and understand what is out in the skies. And once there is an event, there should be communication. There should be enough information to be able to spread the information through school clubs and the media about events, so that people can go out and really observe any eclipses and maybe some meteorites and meteor showers and so many other things. And of course, the whole sky, because we have the constellations and the galaxy. I wonder how many people here have recognized that there is a place that is very densely concentrated area in the sky. We call it Milky Way. Do we know that that is actually our own galaxy? Schools are one part, which is really integral to focus on schools. Communities, we are talking of even our own communities, local communities. We should be able to get our neighbors together to explain what is happening out in the sky. Without the involvement of public, we need to get parents to be interested in astronomy. For example, if I'm giving a talk or giving a present to say stargazing sessions to children, I would also invite the parents, because this is a night activity sometimes. So you need the parents to be around. They will not, otherwise they will not allow their children to go to such activities. So parents are involved. They become knowledgeable. When they go home, they are also discussing this, and they see the importance of this area, so that our governments also can really bring in these ideas and get the public support that they need.
2 minutes, 2 minutes.
Yeah, STEM applications. For example, now here we are talking astronomy as a way of creating really a lot of STEM, because we really lack physics teachers in schools, for example. Physics teachers are extremely lacking. If you go to a school, even if you find one teacher, then you know you are so happy. So we need to increase the number of STEM teachers and students, because we need to attract students to the STEM area so that they can go on and become scientists or technologists to go into technological fields also. Applications and astrotourism, we have said this, and a direct economic benefit there in terms of tourism. Science museums, we do not have. In fact, I just realized that there is a very good science museum in Dodoma here, because it's a geology museum, which I had not known. One of my students who is doing a project in planetariums, I knew that there was somewhere where meteorites are kept. When I visited it, I realized that there is a lot of geological information and the places and the meteorites from which from different places in Tanzania, they are kept there. So science museums is one only. This is a geology museum, but we need science museums where people see activities directly, visually. Industrialization, that is our focus in our government. That really we need to use fundamental science in order to get to develop how to process different products, and using the science and the technology that are available. And astronomy creates new technologies also besides the current technologies that are available. Okay, so now my contention is that here in Tanzania, we are really working, everyone working for themselves, everyone for themselves. And really cooperation is the key to our success. So for example, we need to institutionalize astronomy throughout, everywhere. I mean, the whole country should know that there are organizations that are related to astronomy, there are universities that are offering astronomy, either as programs or courses. For example, at Open University of Tanzania, at UDOM, and at SUA, we have already a lot of connections. But we got a very, very weak response from other universities. So we really are asking for us all to come together to create the critical mass in different fields so that we can. And as I say, when you are starting from zero, you need an infinite effort to get any achievement. So I hope that we will be able to create a proposal for a 5-year implementation plan for developing astronomy in Tanzania. Thank you.
Thank you, Jiwaji. 0 times infinity equals to achievement. Okay. So thank you. Any question to Jiwaji?